Hey guys, I'd like to talk to you about kinetics and how catalysts speed up chemical reactions. So in biology, there's many catalysts. One catalyst is zinc. There's also catalysts in your catalytic converter in your car that help clean up the pollution coming from your car. When a catalyst is a biological molecule, we call it an enzyme. Now, um, uh, catalysts and enzymes speed up kinetics. It's not thermodynamics. Thermodynamics is the decision by the universe that a reaction is possible or spontaneous. Once you have permission from thermodynamics for a chemical reaction to occur, then kinetics will decide how fast it goes. What makes a chemical reaction possible is the idea that reactants have more free energy than products. That's thermodynamics. What slows them down is there is an energy barrier as you go from reactants to products. Now be careful. When I start talking about enzymes, we're going to call the reactants substrates. So I might slip into that. Now, the reason for that barrier is you have to form something called a transition state. The transition state is when the molecule's not, it's, it's changing from reactant to product. And it goes through an in-between stage, which is unstable. Now, the energy you need to do that is called the energy barrier. And the fact that most molecules don't meet that energy barrier threshold, that's what slows down the reaction. Now, I'll give you a little bit of extra, right, for free, the transition state, right? So this chemical reaction includes shows how the transition state might work. So you have a molecule R1 with a hydroxyl group, and it's going to steal the phosphate group from R2. So we see that the phosphate group is going to move from R2, and you see over here it's on R1. In between, it's with both. Now, the freaky thing is, if you look at the R1 or the R2, the phosphorus has five covalent bonds. But when it's in between in the transition state, it has six. That's just impossible. Well, it's not really impossible. It's really unstable. And what an enzyme needs to do is to make that thing possible, is to hold it up, right? Is to hold it up, right? I got some funky thing here. I don't even know what it is, right? If I hold up this object, it will stay unstable in the air. And if I let go of it, it falls down to a lower level. So enzymes hold on to that transition state and make them more stable. So when that happens, the way that looks, if we do the energy profile, here we go, here, right? So because the enzyme or catalyst is holding on to that unstable transition state, instead of the unstable blue pathway, you have the more stable red pathway. And it's easier to take the red pathway than the blue pathway, right? Now, the thing is, the reactant and the product, they haven't changed at all, right? The reaction is possible because the reactant has more free energy than the product. But now the enzyme has made it easier to make the transition state. That makes the reaction faster. So at normal body temperature, chemical reactions are possible that just wouldn't be possible without enzymes and catalysts. And so if you were trying to do the normal chemical reactions of the cell and the body, if you're trying to do them without an enzyme, you really have to cook things and give them a lot of energy to get to that transition state.